I, Professor Neha Dikshit, going to explain you introduction of wire ropes and selection of wire ropes. First of all, we will see construction of wire ropes. Wire ropes consist of three parts, that is strand, wire rope and core. In right hand side you can see all the parts, that is strand, wire rope and core. First, strand. Wire rope consists of a number of cold drawn steel wires twisted into strand. Number of strand, usually 6, 7 or 8, are then twisted about central portion called core to form rope. Core may be natural fiber like hemp or steel wire. Core is saturated with lubricant to minimize corrosion and reduce friction between wires as they slide over one another, particularly during bending. Next is designation of wire rope. Wire rope is designated by three numbers. First number indicates diameter of rope in millimeter. Second number indicates number of strands. Third number indicates number of wires in each strands. We will see example. 35 mm 6 by 19 indicates 35 mm diameter rope with 6 strands and each strand is having 19 wires. We will see example. Second another example. 6 by 7 rope. It means 6 strand and each strand is having 7 wires. Another example, 6 by 37 rope. It means 6 strand and each strand is having 37 wires. Application of wire ropes. Wire ropes used in conveying and hoisting equipments. Flexibility in wire ropes is secured by using large number of small diameter wires. 6 by 19 and 6 by 37 type wire ropes are most widely used. As noted in point number 1, that is flexibility in wire ropes is secured by using large number of small diameter wires. That means 6 by 37 type of wire rope is more flexible. Wire ropes also used in stationary application. 6 by 6 type wire ropes are suitable for stationary application. Now, lay of wire ropes. Two types of lay of wire ropes are there. First one is regular lay and second one is lang lay. Regular lay ropes. Wires are twisted in one direction to form strands and strands are twisted in opposite direction to form rope. You can see in picture. In completed rope, outer wires are approximately parallel to the axis of a rope. Advantages of regular lay ropes. It is not untwist or spin under heavy load. Limitations of regular lay ropes are is they have shorter life. Second type, that is lang lay rope, as shown in figures. Wires in a strands and strand in a rope are twisted in the same direction. In completed rope, outer wires run diagonally across axis of a rope. It can be seen in picture. Advantages of Langley ropes. It offers more resistance to abrasive wear and fatigue failure than regular lay ropes. Limitation, they more likely to untwist under. Now I'm going to explain in short what are the modes of failure of wire ropes. There are two modes of failure of wire ropes. First one is static failure due to the tensile stress and second one is fatigue failure due to the bending pressure. First, static failure due to tensile stress. Direct tensile stress is generated due to the tensile load and direct tensile stress in wire rope is due to the load to be lifted by the rope. Bending stress due to the bending of wire. It is due to the bending of rope around the sheave. Second mode of failure, that is the fatigue failure due to bending pressure. It is due to bearing pressure between wire rope and sheave. Now, next consideration is factor of safety for wire ropes. Depending upon the application, there are factor of safety which we have to select or which we have to consider. For the fixed gauge and jib cranes 4.0, hoisting system in flexible cranes where jibs are supported by ropes, it is 4.5. Cranes and hoist in general hoist blocks, it is 5. Mine hoist and elevators, it is 8 to. Now we will see selection of wire ropes. There are 6 to 7 steps to select wire ropes. For that, first step is the data available with us. First is tensile load on wire ropes and second one is application for which we have to select wire ropes. Second step is select factor of safety for a given application, which I have already explained in previous slide. Third step is select diameter of sheave in terms of wire rope diameter. Diameter of sheave is denoted by capital D and wire rope diameter is denoted by small d. Fourth step is determine diameter of wire rope. For that, used following two equations, that is FF is equal to PBA into capital D into small d divided by 2 and FT into NF is equal to FF. Now FT is tensile load, capital D is diameter of sheave, small d is diameter of wire rope, PBA is bearing pressure. Next step is select standard diameter of wire rope and sheave. Next step is determine bending load, that is FB, and breaking strength, that is FU, using equation, that is FB is equal to capital E into dW into A divided by capital D. In this equation, FB is bending load, FU is breaking strength, capital E is modulus of elasticity of wire material, dW is wire diameter, A is cross-sectional area of wire, and capital D is diameter of sheave. Next, seventh step is determine factor of safety based on static strength. Factor of safety based on static strength, NS, is calculated using this equation, that is NS is equal to FU minus FB divided by FT. Here FB is bending load, FU is breaking strength and FT is tensile load. Now consider here or note here, for safety against static failure, static factor of safety should be more than required factor of safety. Meaning of this statement is you have two factor of safety values, that is factor of safety which you have selected in second step and factor of safety calculated in seventh step. So the meaning of this statement, that is for safety against static failure, static factor of safety should be more than required factor of safety. That means factor of safety in second step should be greater than factor of safety calculated in seventh step. Thank you for listening.